So for the vector question, I chose question number 8, which is a parallelogram has vertices A, -1, 3, and 5, B, 2, 1, and 3, C, -1, 1, and 4, and D. And the question is, find the coordinates of D, the side lengths of ABCD in exact value, and determine the area of ABCD correct to its nearest tenth. So I separated the question into 3 parts, A, B, and C. So yeah, I'm going to start off with the first part, A. So to find the coordinate of D, you first have to know a couple facts about the parallelogram. So I'm going to just draw out the parallelogram first. It's just a rough sketch, so nothing too... So I'm going to label it ABCD. So it has to be in order because that's how you label it. And I'm going to put the points in. So A is -1, 3, and 5. B is 2, 1, and 3. C is -1, 1, and 4. And because we don't know D, I'm just going to label it X, Y, and Z for now, because that's what we're looking for. So looking at this parallelogram, we know that the vector AD is actually equal to the vector of BC, because if we go this way, it's the same as if we started at the top and went this way. And so we can use this to find D eventually. So first we need to find what BC is. So to find BC, we need to subtract the coordinate of C from B. So let's do that. And to subtract, you simply do -1 minus 2 for the x coordinate, 1 minus 1 for the y coordinate, and 4 minus 3 for the z coordinate. So -1 minus 2, 1 minus 1, and 4 minus 3. And this gives you -3, 0, and 1. So we know that BC, the vector BC, is equal to those coordinates. And what we can do with this is equal it to AD, which let's also find. So AD is equal to the coordinates of D minus the coordinates of A. So x, y, and z minus -1, 3, and 5. So that turned into x minus -1, y minus 3, and z minus 5. And what this equals is x plus 1, y minus 3, and z minus 5. And now, because we have these two, since the vector of BC is equal to AD, we can just put the coordinates matching with itself. So, -3 is equal to the x coordinate of there, so x plus 1, and then 0 is equal to y minus 3, so y minus 3, and 1 is equal to z minus 5. And next what we do is just solve for x and y and z. So subtract 1 from both sides, x is equal to -4. Add 3 to both sides, y is equal to 3. Add 5 to both sides over here, and z is equal to 6. So therefore, we know that the coordinates for D is -4, 3, and 6. So there's part A. I'm going to do part B now, which is to find the side lengths of ABCD in exact value. So there's a couple more things we need to know for this one, and that is that similar to here, we know that AD is equal to BC, and we also need to know that AB is equal to DC. And we can tell because if we look at this parallelogram again, AD is the same as BC, and AB is the same as DC. So the question was to find side lengths, and another way to find side lengths is just to add up all the sides. So let's make like a mini equation over here. So side lengths is equal to the magnitude of AD plus the magnitude of BC plus the magnitude of AB plus the magnitude of DC. And because a couple of them are equal to the other one, we can simply simplify it by doing something like this. And the reason I did this was because we already know what BC is, which is this, and we just need to find AB. So note BC is equal to -3, 0, and 1, and AB is equal to B minus A. So B was 2, 1, and 3 minus -1, 3, and 5. And that turns out to be 2 minus -1, 1 minus 3, and 3 minus 5. And that turns out to be 3, -2, and -2. And now that we have both of these, we can just plug them back in to find the magnitude. We can plug them into the magnitude formula to find the side lengths. So let's put them in. So to find side lengths, you usually do the first number squared plus the second number squared plus the third number squared, and then you square root them. So AB is equal to that, so you would do 3 squared plus -2 squared plus -2 squared. And then for the second one, you would do the same. So the second one is -3 squared plus 0 squared plus 1 squared. And let's just simplify that. This one would be 9 plus 4 plus 4. And this one would be 9 plus 0 plus 1. And let's just simplify that. So this would turn into 13 plus 4 would be 17. And this one would be 9 plus 1, which is just 10, so 2 root 10. And yeah, there we go. That's our side length of parallelogram ABCD. So I'm just going to write a final statement here. So therefore, the side length of ABCD in exact value is 2 root 17 plus 2 root 10 units. So yeah, so now we have the coordinate for D and we have the side length. So now we move on to the third part of this question, which asks to find the area of ABCD. So we have to note that the area is also equal to the cross product of U times V. So let's draw our parallelogram again. Ooh, that's an ugly parallelogram. It's just a rough sketch, so that's fine. So this is A, B, C, D. And so because we only need this side and this side to find the area, I'm just gonna let U equal AB and let V equal AD. And so we know that AB is equal to 3, -2, -2 from the last question. And we know that AD is equal to -3, 0, and 1. Right? So now we can use those vectors to cross multiply to find the area. So let's set up the cross multiplication. So U, V, I, J, K, and I would be 3, -2, -2, and this one would be -3, 0, and 1. So to cross multiply, oh, right, so the area is the magnitude of the cross multiplication. I think I said the wrong thing before, so just to clarify. So now we're just doing the cross product. So to find the cross product, we cover the first side to find the first coordinates. So cover that up, pretend that's not there, just draw a line through it. So the first step is to multiply -2 by 1. So -2 multiplied by 1 multiplied by -2 times 0. So minus -2, 0, comma. So that's this part is our x coordinate, and this part is going to be our y coordinate. So the y coordinate is always negative. So, and to do the middle one, or the y coordinate, you have to cover up the middle one. So you do 3 times 1 minus -2 times -3. So you do 3 multiplied by 1 minus -2 multiplied by -3. And then, so that's your y coordinate. And your z coordinate is similar. So you cover the last one, you multiply 3 by 0, subtract -2 times -3. So you do -3, oh no, +3 times 1. No, oh sorry. You cover the last one, so -3 times 0. So -3, 0, minus -2 times -3. And that is our z coordinate. So now we just have to simplify. So this turns into -2 minus 0 plus 0. This one turns into -3 minus 6. No, +3 minus 6. And then the next one becomes 0 minus 6. So 0 minus 6. And that turns into -2. Inside there's -3, so it becomes +3. And the last one is just -6. So that is our cross product. And because we need to find the magnitude to find the area, we need to use the magnitude formula. So E times V, the magnitude would be -2 squared plus 3 squared plus -6 squared. And that gives us 4 plus 9 plus 36. 13 plus 36 is 49. And the square root of 49 is, of course, 7. And there is our area, 7 units squared. So I'm going to write a final statement here. Therefore, the area of ABCD is 7 units squared. And yeah, so to recap, we found the coordinate here, we found the perimeter or the side length here, and then we found the area here. And yeah, that's how you do question 8 of the vectors culminating question.